So we're going to use what you learned yesterday to apply to a situation, okay? Because what we learned yesterday about directions has a lot of real-life applications to a lot of occupations, right? Just out of curiosity, take a moment. Can you think of anybody in the real world that might need to know how to do trig with directions like this? Why?
Because they need to know where to go.
They need to know where to go, right? Okay, good. So Javon says army, right? You got to move a whole bunch of people from point A to point B, right? You can't say, just go over there, right? Yeah, that way. Okay, good. Can anybody else think of another one?
Marines.
Same thing. Armed forces. Fine. Karen. Oh, yeah. Hey, not bad. Could be. Could be. What else? Pilot. Yeah, that's a big one, right? Because taxi and stuff, you're kind of stuck on the streets, yeah? But pilot, there's no street. You just fly wherever you want. What else?
Not really, like everywhere you want. Like,
Well,
there's some boundaries, probably.
not up in the sky.
Well, like, you can't just keep going up, and you can't go, like, a
You
certain
can get up to a certain height, and you're allowed to fly everywhere.
What if you're, like, basically in space?
Then you can fly everywhere.
You kill everyone then.
No. There are planes right now that go to the edge of space.
That's, like, the edge. I'm talking about, like, in.
Well, no, of course you can't go into space.
Yeah.
But once you're in space, you're no longer flying.
Well, you could be.
No,
because your
you're in
engines
space. You are no longer flying. You're floating.
Bunch of engines, stuff like
No, not if you're in space. In space, you're in free fall. That's how it works. Quick bit of science. Earth has gravity.
that. Yep, I knew that.
The gravity pulls you towards Earth.
Yeah.
But your rocket ship, we're going on a trip on our famous rocket ship, is falling down here until it gets past halfway. And then Earth's gravity picks it back up. But you're technically falling still. Even though in 2 dimensions I'm drawing it going up, you're still falling. You're always falling. So you're not actually flying. Once you are in orbit, there is no need for any energy to expend. You just keep spinning. Back to math. Pilots. Search and rescue. Right? The plane was flying this way. It was flying at this speed for this amount of time, and now it's gone. How do you find it? Right? Rangers, tracking animals, migrations, things like that. There's all kinds of real-life application for this, yeah? Now the argument always becomes the next thing, well, I'm not going to do any of those things, so I'm not going to learn it. Cool, that's fine. Everybody's good? All right, so now let's use what we know to solve a problem, all right? So I'm going to give you, now this is a math problem, obviously, right? But let's say Myers walks for 18 km at a heading, and again, you don't need to write this down, at a heading of 57 degrees. He then turns south and walks until he's directly east of camp. How far to get home? Okay? Everybody cool? All right. So, there's the drawing, and again, you don't need to write it down. If I was going to be working this question, I start walking in a direction, yes? So what is the first thing I need to do if I was going to work this out? If you had to find me in the middle of the woods, and I had told you, hey, I'm walking off at this heading, what was the first thing you would do?
Compass.
You'd draw a compass. Excellent. And where do you start walking from once you draw that compass?
57.
No. Where do you start?
0. Like the center.
The center. Here is where I would start. Yes, I'm going to use a different color.
Yeah.
Everyone agrees, right? Now I walk off at a heading of 57 degrees. Where's 57? Right or left of north? Right. So I'm going off here. Where is the 57? Is it there or there?
There.
Top or bottom of the pink line?
Bottom. Because that's bigger than 45.
I'm waiting.
The bottom. Bigger than 45.
You've said bottom, but Josh is saying top. There's a disagreement.
Well, I did say bottom, but
Then you change your mind.
well, I changed my mind because
From where do we start counting? 0. And so I start going this way. So where's the 57?
Bottom.
Again, we're disagreeing. I start counting at 0.
It only goes
Again, no. Again, what have I told you about the drawings? Why are the drawings there? To help you. Are the drawings an actual depiction of the thing in the real world ever? No. So I'll ask again. Where is the 57? Over here. Why? Because I start counting at 0. And I went to 57. Okay? Yes, I didn't draw it right. But that is not what this is about. You have to know what is actually happening. So this is 57, yes? Is everybody cool with that? I walked for how far? 18 kilometers. So I walked this way for 18 km, yes? And this is 57. Agreed? What happened when I got to 18K?
you turn south
I turned directly south, yes? Okay.
until you're exactly.
Until I'm exactly east of where I started. Which would be right there, yes? Is everyone happy with my drawing?
Yeah.
Excellent. Now the question is, how far away from home am I? So I am now right here. How are you going to figure out how far away from home I am? Which side of the triangle do I need? Yellow, blue, or green?
yellow.
Excellent. To do trig, I need what kind of triangle? A right angle triangle. Do I have that? Yes, because I went directly south until I was directly east. Agreed? So I have a right angle. Excellent. Can I do trig yet? Sure I can. If this is 57, what's that?
Oh,
33. Do I have a theta now? What is it? 33. What else do I have? I have an hypotenuse, don't I? Okay. And what do I need? The yellow line, which is what? Adjacent. Now I'll ask you again. Can you do trig right now? No, why not? You haven't been taught what to do with an hypotenuse, have you? What have you been taught? What to do with legs only, correct? But you're intelligent young people, aren't you? Yes, you are, Simran. You're very intelligent young people. You're intelligent young people, yes? You know that there is a relationship outside of trigonometry between the legs and the hypotenuse, yes? And you know that there's a relationship inside trigonometry between the legs, yes? So logically, must there not be a relationship between the legs and the hypotenuse inside trigonometry? There must be, yes? But you don't have it yet. Everybody cool? Doing what we did, you know that in literally the next thing I'm going to show you will allow you to solve these problems, yes? But look at how far you got without knowing that last step. Is everybody with me? You all, very few of you, if any of you, drew it, but you all can see how you could get to a point where you could tell me that yellow if you had the tool to do that job. Yes? Is everybody comfortable with that? Comfortable with saying, I have no idea what to do, but I know I could do it if I knew, if I had the tool. Right? Everybody is comfortable with that, yes? Because all of you know how to do stuff with trig using a theta and some of the sides, right? The only problem for you right now is you don't have what relates to the hypotenuse. Is everybody okay? Great. Now you're actually going to start writing stuff down by going to page 58, please. Yes. Now, quick reminder. What trig do you already know how to do? Right. You know that the tangent of any theta is the opposite leg, and I'm going to highlight leg. Why? Because you can only do tan with legs, never the hypotenuse. Divided by the adjacent leg. And I'm going to doubly highlight adjacent leg. Why am I taking extra time to doubly highlight adjacent leg? Pardon me? Yep. But, again, here's my triangle, there's my theta. Opposite's easy to find, isn't it? What's opposite? Across. So adjacent must not be what's across. But there's two sides that aren't across. So why am I doubly highlighting the word leg here? Because you don't want to use the hypotenuse when you're doing tangent. The adjacent leg is never the hypotenuse. Everybody good? All right. So this you already know, correct? And you've just found out that if you have a tool, you can do stuff for hypotenuse, yes? Now, if you read that little paragraph right there, you know the first word, tangent. Not the only trig ratio. As you already know, there must be ratios that deal with the hypotenuse. And their names are as follows: sine and cosine. Now, if you look on your calculator, what's right beside the button tan? Cos, or cos, and sin, or sine. Now, do you already know how to use the tan button? Excellent. If something happens once in math, how often does it happen? So, do you think that since sine and cosine deal with trig ratios, and tan is a trig ratio, do you think the method is the exact same? Of course it is. So let's talk about that. For any specific angle. Now, the specific angle, what is the name that we have given to the specific angle that we are going to use? Not quite. It is a letter, but it's not X. And it's not a letter in English. Theta. For your theta, whatever it is. When I say specific theta, and that is your theta. That is the angle you care about. Okay? It can be any angle in the triangle. Remember, in tan, it's not allowed to be the 90, is it? But in sine and cosine, it is. So it's the theta that you care about. Cool? Sine compares the opposite. Soon as I say opposite, is it a leg or hypotenuse? Leg divided by the hypotenuse. So you're intelligent young people, even though Simran says you're not. If tan is opposite over adjacent, and sine is opposite over hypotenuse, what, therefore, must cos be? Adjacent over hypotenuse. And adjacent is what? A leg or an hypotenuse? A leg. Everybody cool? All right. Let's see how cool yous really are. That sets up this pretend word. It's not a real word. There is no, if you go into the dictionary and you look up SOHCAHTOA, you will not see a definition because it's not a real word. It's like never eat soggy wieners, to remind you of Northeast, Southwest. It's what's called a mnemonic device. Some of you have heard of what that is. Some of you haven't. That's what this is. It is a mnemonic device. And it stands for the sine deals with opposite and hypotenuse. The cosine deals with adjacent and hypotenuse. And the tangent deals with opposite and adjacent. Now, do you need to memorize this? Have I made you memorize any other formula? No. It's on your data booklet, that sheet that I tell you to bring to every class that most of you have lost now. Right?
Yep.
Everybody knows the sheet I mean. Now, listen to me and listen to me carefully. We're going to draw a triangle. But we're not going to draw no baby triangle. We're not going to draw no triangle like this. Because that's kindergarten triangle. Anybody can do that. We're going to draw us a grown-up triangle. A bad-ass triangle. A triangle that gets the snakes off the plane. Okay? Somebody must get that reference. It's a horrible movie, but has a great line in it, which I can't repeat because it's a school. We are going to draw this triangle. Way. And we are going to put the right angle up there. Take a deep breath. Stay cool. I know you can handle it. Then we're going to name the angles. How do I label those angles to do it properly?
Isn't there just two ways?
Not for angles.
Oh, yeah.
How do I label the angles in a triangle properly? Talk to your neighbor if you don't remember. You may want to flip back a couple of pages in your notes to see if you can find it. I have to use ABC, Martin? Any letters. What has to be special about those letters if I am dealing with the angles? They have to be capitals. I'm not going to use ABC for a reason. I am going to use A, B, and Q. Everybody cool? All right. Now, you label the sides and label them properly. Go. Josh. Pardon me? The Q, it is, I am using Q for a reason, which I will tell you in one moment.
Dunzo. Oh, wait, I gotta do that. Wait.
So what is the proper label for this side?
Lil Q.
Karen. Lil Q. I am using Lil Q because the lowercase q looks different from the big Q. If I use C, it looks almost the same, and that can be confusing. So what is the name of this side? Lil A. And what is this side? Lil B. Which letters are legs? A and Q. Which letter is the hypotenuse? B. Why do you know that, Nicholas? Because normally the hypotenuse is the diagonal. So why do you know that B is the hypotenuse here? You're not Nicholas. You're a good-looking cat, but you're not Nicholas. Which you, of course, being a teenager, is like, he just said I was ugly. But what I actually just said was, you're not Nicholas, because you're Javon.
Yeah, I know.
Go.
Because it's the right angle, and so A and Q would be the legs.
Right. It's across from the right angle. Does it matter how I turn that triangle?
No.
You can always find the hypotenuse. Why?
It's not always opposite.
Because the right angle points at it, right? Okay, now, here is where you show off and prove to Simran that you're intelligent young people. Tell me the sine of Q, the cos of Q, and the tan of Q. Talk to your neighbor. You have the tools you need to solve this. Don't worry, your neighbor won't bite. They're good people.
We're talking about how confused we are.
How can you be confused? You all told me you understood this and this.
Yeah.
Okay, so if the sine of the theta, the angle you care about, is opposite over hypotenuse, which angle do I care about in this one? No.
Or the, yeah.
Which angle do I care about? No. Which angle do I care about? Q. And the sine of theta, which in this case is Q, is the opposite value divided by the hypotenuse.
Oh, okay. Got it.
I'm a little confused as to how you were confused. When you said, I got it, I got it, I got it, and then I don't got it. Who would like to tell me the value of the sine of Q? Jovan. Lil Q over Lil B. Now, the reason you are scared is because I didn't give you any numbers. But that is no reason to be scared, is it? Because the value of sine is not a specific number. It is whatever the value opposite of your theta is, divided by whatever the value of the hypotenuse. Now, since you did not get numbers there, the only values you have are Q and B. What then is the cosine of Q? Josh. Lil A over Lil B. What then is the tangent of Q? Karen. Lil A over Lil Q. Any problems? Now stop for a moment and really think in your own mind without thinking of anything else if you need to stop me because you are at all confused. Because if you don't, I am going to move onwards and you will be left behind. Jovan. I didn't check. Little Q. Yes, thank you. It's opposite over adjacent. So it is Lil Q over Lil A. Now it's fixed. Everybody is good? All right. Now you are intelligent young people. What is the sine of A? The cos of A and the tan of A. Since nobody stopped me here, you should all be able to do this. If not, then you've been lying to me. And that hurts. That makes my 3 sizes too big Grinchy heart shrink a little bit. But my Grinchy heart has armor. It will grow back. Would anybody like to volunteer the sine of A? Javon. A over B. Would anybody like to volunteer the cos of A? Marcos. Q over B. Would anyone like to volunteer the tan of A? Josh. A over Q. Excellently done. What do you notice? The sine of Q is the cos of A.
No way.
The cos of Q is the sine of A. And the tangents are reciprocals. Is everybody cool? Yeah? Okay. Now, is this still trig? Yes. Do you have a method for doing some kinds of trig problems? Yes. In math, if something works once, how often does it work? Always. So if you have a method that works with tan, will that method work with sine and cos? Of course it will. Let's follow that method. In this triangle, do I have a theta, which is the angle about which I care? What is it? Theta is 12. Once you have theta established, you know that is where you are going to be looking at the triangle from, right? There I am, looking at the triangle from my theta. Once I have decided where I am going to look at the triangle, do I then know what is opposite to me? Do I then know what is adjacent to me? And do I then know what is the hypotenuse? Excellent. So looking at what I have, what do I have? I have an opposite. That opposite has a value of what? X. What else do I have? I have an hypotenuse that has a value of what? 25. What uses O and H? Sine. The sine of theta equals O over H. What is theta? 12. What is O? X. What is H? 25. Now, if this SIN said TAN, you would know what to do, correct? You would do 25 times tan 12. But it does not say tan, it says sine. So what do you do instead? You use the button that says sine. Because the math doesn't change, the button you hit changes. 25 sine 12. And what do you get? Adrian. 5.919. I would, of course, accept 5.2. Does everybody understand? Now let's check and make sure that that makes good sense. Is 12 a very big angle? So if I'm flat, 12 isn't very tall, is it? I've drawn it tall so there's room to do the work. But in reality, 12 is only from this bottom of the protractor to where the ruler is now. You can see how very little it has gone up. Yes? Now, since it has gone up very little, this number must be significantly smaller than my hypotenuse. Is it? So did we do it right? Yes, we did. Does everybody understand? Cool. Does the method change? No. What is the only thing that changes when you are doing trig? The button you push on your calculator. What determines what button you push? What you're trying to find and what information you have. Everybody understand? So let's follow our method. Do I, in the second triangle, have a theta? What is it? 19. Once I have 19 established as theta, where do I go? To that angle, and now I know my opposites, my adjacents, and my hypotenuses. Yes? Great. What do I have? I have an h that is x. How did you know that was the hypotenuse, Karen? Because it's across from the right angle. Even though the triangle has been turned, we know that the hypotenuse always lives across from the right angle. What else do I know? Why do you know that is adjacent? Javon?
It's not the hypotenuse, but it's like
Because it's not the hypotenuse, but it's still beside theta. It's the leg beside theta. So my adjacent is what? 40. What uses A and H? Cosine. Cosine of theta is A over H. Cosine of not theta, cosine of 19 equals A, not A, 40 divided by H, not H, X. How do I solve that? I would multiply both sides by X, and then what? Divide, but not by 40, by the cos 19. So eventually I'm going to need to do 40 divided by cos 19, yes? So I could do all the algebra, or I could remember that shortcut. When the denominator is an x, we end up at the end of all the algebra, we do 40 divided by cos 19. And what do I get? 42.3. Check. Does that make sense? Well, 19's not very far, is it? Is it? This is 40, and then I didn't go very far that way, so my hypotenuse can't be very much bigger than 40, can it? Is it good? Yes. Now let's pretend you can never remember if it's multiply or divide, or if it's 40 divided by cos 19 or cos 19 divided by 40. Let's pretend you can't remember that. You can't remember that one simple fact. And you don't want to do the algebra. You want your shortcut. Because you're North American math kids and you always want your shortcut, right? Yeah. Let's pretend you can't remember that shortcut. Well, then you go to your calculator and you would go, okay, cos 19 divided by 40. 0.023. Can that be the hypotenuse? Of course not. Why? It's shorter than 40. And the hypotenuse is what? The longest side. Everybody cool? Now, just to remind you, some of you are going to say, I still don't remember, Mr. Myers. Then make sure you can actually do algebra. And to actually do algebra, you have to be able to (10 equals 50 divided by x. You multiply both sides by x. So 10x equals 50. Then you do x equals 50 divided by 10. And then you remember that if you once you switch these places, what do you do every time? Switch those places. Everybody cool? Sweet. Now look at the third one and tell me what is different. Don't do any work yet. Just look at it and tell me what's different about it. Jovan? I don't have a theta. I don't have an angle. But I know from tangent that not having an angle means shift tan, right? So what does not having an angle with sine and cos mean? Shift sine or shift cos. How do you know which one to use? How did you know which one to use in the first two? Yeah, if it was A and H or O and H. So does anything change here? No. Is it difficult? No. I follow the same set of rules. Do I have a theta? No. It's x. But I know that that's my theta, so I truck on over. And now I'm there looking for O's, A's, and H's. What do I have? What do I have? I have an adjacent of what value? 13. What else do I have? And hypotenuse of what value? A and H uses what? Cosine. Cos theta equals A over H. Cos not of theta, x, equals what? Not A, 13 over not H, 22. Oh, I don't have an angle. My unknown is over here, so it must be shift cos of what? 13 divided by 22. And you're going to do that with your calculator however you do it. And then you're going to tell me an answer. And what is it? 54 degrees. And everybody remembers that degrees we round to the nearest degree. Now, ladies and gentlemen, you will notice that we only did 3 questions of sine and cos for practice, yes? But we did a million tangents, yes? Why? It's the same thing, isn't it? You also should notice that if you write it out, is it possible to do it wrong? It really isn't, is it? I give you SOHCAHTOA. I give you what it all means. And if you look on your data booklet, does it not also draw the triangle to actually show you where O, A, and H live? It does, doesn't it? So everyone is cool, yeah? Now listen, there's a long time left in class. 37 minutes. You have a 3-day weekend that you do not wish to spend any time on homework, yes? But I need for you to be able to do everything on 59, which you will notice is all just triangles, yes? Not real life. And everything on 60. And you will notice on 60, there are a couple of real life questions. Now, please notice number 7 on page 60. The photocopying is a little shabby, yes? So, it is, if I am not mistaken, 25.23, and that looks to me like it says 56.5, but I am not sure. Degrees. I want you to use these measurements to do this question, which means if I'm wrong about that value, then your answer in the book is going to be wrong, yes? So don't be bothered if that is the case, because I only think that says 56.5. Does it, can you see it better at all? You think it says what? 50. 50, straight up 50, not a 0.5? You think it's 50.5? Can everybody have a look and see? Because you can obviously, on mine, it looks like crap. I just want to get to an agreement. You think it's 50.5?
I think it's 55.
You think it's 55.6? Yeah. Holy crap. 55 point... Okay. Okay. Well, a lot of people are going 55, so I'm going to go with 55.6. Now, is that normally how we measure degrees? No. But since it was given to you with 55.6, what is your theta going to be when you do this question? 55.6. You would not round it. Everybody understand? So your job, and you have until Tuesday to do it, is page 59 and 60. Now, I know the answers are there, but that is no excuse not to try it. Yes? Go.